Good afternoon, everyone, and welcome to this Mobile Talk session about challenges, opportunities, and security concerns of 5G organized by Mobile World Capital Barcelona. First of all, I want to thank especially the US Embassy in Spain and Andorra. And some months ago, they shared the idea of inviting one of the most renowned experts in IA, cybersecurity and wireless systems in the world, Mr. Charles Clancy. We had no doubt that we wanted to be there. Although the initial intention was to organize a series of physical events throughout Spain, COVID-19 made it impossible. And then we decided to go digital. Hoping to have the opportunity to enjoy Charles Clancy knowledge and experience in Spain in the near future, today I'm sure that we will have a taste. Before we start, I wanted to share with you our motivations in order to organize such an event. Some 3 years ago, more or less, Mobile World Capital decided to take a strong bet on 5G by dedicating one of our 4 main strategic pillars, the 5th generation of mobile technologies. If you remember, by that time, 5G was getting traction in some countries in Asia. US started to see it as strategic, and it seemed that EU in general and Spain in particular could lose track. Although the 5G promise was clear for us, the industry in Spain was immersed in huge 4G and fiber investments, and applications, future services, and business models were not that clear by that time. And our institutions were not pushing very hard. But the European Commission had some figures, some numbers that recommended us to take this bet. By that time, they were talking about creating 2.5 million new jobs in Europe and adding to the European GDP somewhere between 120, 150,000 billion euros. So our mission at Mobile World Capital has to do with the acceleration of digital transformation of society. We decided that we wanted to contribute to accelerate the 5G network deployment if we wanted to have a competitive economy and a strong and healthy society. By that time, we created the 5G Barcelona Alliance together with the regional government of Catalonia, the city of Barcelona, some R&D centers led by I2CAT, the Polytechnical University of Catalonia, 3 main MNOs in Spain, main equipment manufacturers and other cloud and technology companies got on board, and we started to work. Since that moment, we have identified nearly 100 use cases in different sectors. We have activated more than 20 pilots, partnering with Spanish relevant companies like Football Club Barcelona, Spanish Volkswagen Group brand SEAT, Acciona, Ferrocarriles Generalitat de Catalunya, Hospital Clinic, in areas such as entertainment, sports, motorsports, mobility, infrastructures, industry 4.0, healthcare, emergencies, broadcasting, logistics, and smart city. We have traveled throughout the territory, organizing workshops for institutions, journalists, industries, sectors, and companies. And we have created labs with pre-commercial equipments of the most relevant equipment manufacturers available for corporations, SMEs, and startups. On the other hand, we wanted to have a real picture of the 5G situation in Spain, and we created, together with the government of Spain, the National 5G Observatory, together with the Secretary of State of Telecommunications. Last month, we achieved an important milestone. Okay, finally, the 4 main Spanish MNOs decided to start their commercial plans for 5G. So now, what? Well, now Mobile World Capital will try to help the industry in developing the future internet services, disruptive services, that will run over the new 5G network, creating business models and defining a pricing strategy that makes sense on ensuring that nobody stays behind this new reality. And of course, one of the main challenges that we want to face is the one related with security. And that is why we decided to organize this event. I hope you enjoyed the program today. Remember that you can send us your questions during the whole session, either via Twitter using the Mobile Talks hashtag, or using directly via YouTube via YouTube Live if you are watching us at Mobile Talks website. And without delay, let me introduce Mr. Charles Clancy, Senior Vice President, General Manager of MITRE Labs, and Chief Futurist at MITRE Corporation, a non-profit organization that advises and develops research and systems engineering in the field of information technology to the US government. As his CV is quite impressive, I'll just remark that he's an internationally recognized expert on wireless, cybersecurity, and AI. He's a member in many defense, intelligence, and security committees in the US. He's been professor at Virginia Tech, director at the Hume Center, leading research in defense and intelligence. He started his career in the National Security Agency, co-author of 250 patents and academic publications, and has written 6 books. And a Finnish, co-founder of several security startups that apply commercial innovation to national security challenges. So, Mr. Clancy, the screen is yours.
Thank you. So let me share my presentation. One moment. All right. Well, thank you for that generous introduction. I'd like to start the discussion today with a little bit of an overview of 5G. As some of the panelists were remarking before we began the broadcast, to many, 5G is just one higher number in front of a G when it comes to mobile communications. And it's really important to understand the fundamental attributes of 5G and why it is so revolutionary and so important. From there, we'll go into some of the security discussions. What are the new security features in 5G? How has it improved upon 3G and 4G? And then we'll talk about some of the emerging technologies for securing sort of user traffic that really are tied to these emerging zero trust architectures. And then we'll continue into the panel discussion. So first, high-level 5G architecture. So this is my personal depiction of it. There are lots of different ways of drawing it and rendering it, but I think this really helps get to the heart of what's fundamentally different in 5G. So at the very bottom, we have our cloud infrastructure. Historically, we've thought about the cloud as compute resources that sat in a data center. And really, our data centers were connected to the internet through our telecommunications infrastructure. I think the really important thing to understand with 5G is that now the cloud is not just confined to a data center. The cloud is really everywhere. Our telecommunications core networks are implemented using cloud resources. Our edge access networks are also all based on cloud technology. And so historically, we've thought about the cloud sort of sitting on top of the internet. But with 5G, we're really flipping it and turning the internet inside out. And as we move forward, really the internet is sitting on top of the cloud. And so it's a fundamental thing to understand is that because of this flip, everything is virtualized, and that gives us extreme flexibility in how we compose our networks and deliver services to a whole new emerging set of users and applications. So across the bottom layer, we still have our data center clouds. That's where the large scale compute still happens. But we also have cloud infrastructure within our telco networks and within our edge access networks that are really creating this environment of fungible and ubiquitous physical compute network and storage resources that are really spread throughout our environment. Now, on top of that, we have a layer of virtualized control, management, and orchestration. So again, if you have all these virtual resources, you have to know how to compose them in a way to deliver a service that is relevant to your customers. And you have to be able to manage those customers, manage their connectivity, and so forth. This is a fundamental shift from 4G and earlier. In 2G and 3G and 4G, we had fixed function equipment. So it was a piece of hardware running a real-time operating system that was designed to do one thing and one thing only. And so if you wanted to expand your mobile network infrastructure, you just bought more of those pieces of equipment and installed them in racks in data center environments. But now everything is virtual. So I can launch an entirely new segment of my network virtually by spinning up additional microservices in a virtualized cloud environment. So this elasticity and the ability to rapidly reconfigure and reprogram the network is the key innovation, in my opinion, that we're seeing with 5G. Of course, there's a whole bunch of fun things happening on the radio access network as well. New technologies and standards for increasing the data rate between devices and the network. We have, of course, all new spectrum that's in play for 5G with millimeter wave spectrum, now giving us opportunities for extremely fast connectivity and sort of whole new business models around how we deploy and manage spectrum. But today, as we talk about security, I think the heart of it and the heart of the innovation is really in how all that intersects in the core network. So we have this very elastic and reprogrammable and responsive substrate upon which we can build any network we want. So what kind of networks would we want to build? So the top layer is what we'll call these network slices. So in 5G, you can establish a network slice, and it is logically isolated from the rest of the network. It can be designed to serve an individual class of users, an individual company. On the left, we have three broad use cases that are defined within the 5G standards and the 5G ecosystem. So first is enhanced mobile broadband. Enhanced mobile broadband is really about doing what all the great features of 4G, only doing them faster and with higher capacity. 4G today, depending on where you are in the world, struggles to deliver 4K and certainly 8K HD video in congested areas. 5G will give us the capacity we need to deliver 4K and 8K HD video to everyone all the time, just because we'll have more resources and more capacity in the network. The next broad use case is massive machine type communications. And here the goal is to connect 1 million or more devices per square kilometer. So in this scenario, think about a dense smart city with everything in that city instrumented and connected to the internet. And so in this environment, it's not so much a question of capacity as it is a question of density, and how do you support a relatively low data rate, but for potentially millions of devices in a dense area. So that requires something different from the network than just supporting faster data rates to smartphones. The third broad use case is ultra reliable low latency communication. And this is really for the real-time services. So anything, often think about safety critical functions such as autonomous vehicles, where you need to do sensing on a distributed platform that is sending messages to a controller that might be in an edge cloud that's making real-time decisions about how to control physical things in the physical world. So it's that closed loop, low latency, real-time cyber physical system, and the ability to get your latencies down low enough that you actually can do that real-time control of your cyber physical systems, whether it's a factory process in a smart factory or smart manufacturing facility, or it's autonomous vehicles, or it's drones that are doing collision avoidance or safety algorithms that need to coordinate in a real-time nature. So in ultra reliable low latency communications, we seek to achieve below 1 millisecond latencies. So the important thing to understand here is we've got three different use cases, all requiring very different things from the network. The first use case, mobile broadband, we want hundreds of megabits to gigabits per second of throughput. The second use case, we want millions of users per square kilometer to connect, or millions of devices. And in the third scenario, we need to have sub-millisecond latencies for all those devices. And to a certain extent, it's impossible to achieve all three of those things simultaneously. So that's really where the network slices come in, is it allows you to group together and allocate resources that are designed to meet the quality of service requirements of those specific applications. So that's really the importance of 5G. And so the rationale of why it's heavily virtualized is that now it gives us the tools in the toolbox to implement this industrial Internet of Things in a way that really wasn't possible with 4G as we know today. So let's talk then about some of the security properties of 5G. And so I'm particularly going to be talking about it with respect to 4G. So first of all, so I break it into four different areas, the RAN, the core, the roaming interfaces, and then some of these new slicing and virtualization opportunities. So specifically within the radio access network, or the connection between your phone or an IoT device and the cell tower, there's a few things that were fixed in 5G. Researchers had discovered a number of vulnerabilities in the 4G standards They were all relatively minor. They really have only been demonstrated in isolated laboratory settings. So this isn't necessarily a broad concern for the industry and for the 4G deployments we have today, but still it's good to fix them as we go into 5G. So in particular, the 5G standards encrypt the identity of your device when it first attaches to the network. That way a rogue base station can't fool your device into giving up its identity. And this is a concern from a law enforcement, certain public safety law enforcement using this that might in a way that would compromise privacy. So that's been addressed in the 5G standards. The second is that we're encrypting more of the traffic between the phone and the tower. In 4G, we had certain channels that were integrity protected, certain channels that were encrypted, and the choices that were made in 4G made sense at the time. We found that that's led to some corner cases of potential vulnerabilities. So in 5G, we've expanded the requirements for encryption and identity protection between the phone and the network in both the data channel and the control channel. Moving into the core network, as I mentioned, we've completely changed the way our core network operates in 5G. We've thrown away the fixed function resources of 4G, and we've now moved into this very dynamic and agile cloud-based environment. And so here we now have microservices that are implementing all of the functions in our core network. And this means that we need a new way to do authentication and encryption between those services. So it's no longer the need to protect a physical connection between two fixed function pieces of equipment where maybe it's just a single network cable that's connecting the two. Now you have all these services in the cloud, and they each need to have their own digital identity and certificate that can be used to mutually authenticate and ensure that these microservices are all appropriately interacting within the cloud network. Additionally, we have a whole new set of options that have been made available for security in the core network beyond just using TLS, which is the transport layer security that's encrypting the individual sessions and authenticating the individual sessions. We also have the ability to use IPsec for network layer encryption of data that might be moving between parts of the network. And we actually can even do more fine-grained encryption and authentication of individual messages and attributes that are going back and forth between the microservices. So 3 different layers of encryption that we can stack together in order to ensure that the authentication and authorization we seek from our network is being achieved. The third is in the roaming interface. So if, as we moved from 1G to 2G, we addressed big issues around consumer fraud that was happening in the 1G networks. As we moved from 2G to 3G, we addressed issues with mutual authentication between phones and devices. As we moved from 3G to 4G, we began to address some of the roaming interconnect security challenges that we saw with 2G and 3G, but we still have a ways to go. If you look at kind of rewind 2G and 3G, all the control roaming interfaces were based on the SS7 standard, which had no authentication and no encryption. And that's led to a series of vulnerabilities that have been demonstrated and exercised by hackers. As we moved into 4G, we still have, encryption and authentication, but it's not end-to-end, it's hop by hop. And so particularly as you have roaming intermediaries that serve as aggregators for all the global mobile networks to interoperate with one another, you get some security, but you don't get end-to-end security. And what we see with 5G is they've introduced this new set of protocols that enable end-to-end protection of data through these roaming interfaces so that you know exactly the network a subscriber is originating from, and you can authenticate billing records and things of that nature that might be traversing between a roamed network and a home network. And the fourth area that I think is really important to understand is, as I mentioned, this notion of slicing and virtualization. I talked about it in the context of meeting quality of service goals for these applications previously, but it also can be a tool for security. So if I go back to my previous slide, rather than implementing one of those virtual network slices purely to meet the quality of service requirements of autonomous vehicles, let's say, I also can deploy security appliances virtually into that network. I can put firewalls virtually into my core network. I can, if I identify some sort of distributed denial of service attack, I can virtually deploy appliances to block the denial of service traffic as it's coming into the network, not when it's hitting the point in the network that's causing the congestion or the destination of the attack. So it allows us to push our safeguards further out into the network and elastically and dynamically deploy and redeploy all of the security appliances within our network based on the threats that we're observing and experiencing. So if there's some sort of large-scale botnet we need to deal with, we can virtually deploy the resources to address that. So this opens up a whole new set of opportunities for securing our 5G networks, and it's really exciting. The challenge, of course, is we just don't know how to do it yet. It all exists in PowerPoint, but it doesn't exist in real-world implementations that you can go buy and deploy and use today. So in particular, in my role with the MITRE Corporation, we're doing a lot of work with the US federal government around their interest for secure 5G here in the United States. And again, there's a lot of opportunity for creating secure network slices that could support the federal government, that could support high-risk commercial industry, that could support smart grid. You could have a network slice for smart grid or autonomous vehicles that could be isolated and secured. But the equipment just isn't available yet to deploy. I talk about this in terms of this responsive, elastic redeployment of resources. But right now, the technology just isn't mature enough yet. It's still very manual and human-driven. As we move probably over the next 2 years, we'll get to the point where we have the standards matured, the equipment developed, deployed, and tested in our network, so we can actually do all these exciting things I'm talking about. And the last topic I want to talk about is zero trust architectures. So zero trust has been around for several years, but it's been viewed traditionally more in the enterprise network context. And I think what we're beginning to see is a desire to more systematically integrate it into our mobile networks. Certainly here, my own experience in continuing to work in the middle of a global pandemic is that many of our employees in my company are working from home. And as an example, we issued every single one of our employees a mobile device so that they could remain connected. And we shifted to Microsoft Teams so that we had the ability to do real-time video among our employees to continue to support doing our work. The challenge, of course, is that in the traditional model, my mobile device establishes a VPN session to an enterprise VPN concentrator. And so my phone needs to communicate with Microsoft Teams. So I have an AT&T phone that's talking to an Azure cloud, but all my traffic has to go through an enterprise VPN concentrator that becomes a choke point for traffic. And so are there ways that we can achieve security where my phone can establish a secure connection directly with Azure that meets all of the government security requirements without having to use bulk encryption of all of the network traffic going through a corporate network, as an example. So we're seeing a lot of need and interest just because the topology of how we work is changing. It's not people necessarily connected to an enterprise Wi-Fi network sitting in an office. We now have people everywhere that need to access services. And so zero trust is, I think, even more important as we look at new enterprise, mobile enterprise connectivity models for a distributed workforce. So within zero trust, again, this is a vast oversimplification of a lot of the technologies that are emerging right now, but just to give you a sense, is typically you'll have a user sitting on the left side here. User wants to access some sort of cloud service on the right. In my case, it's my mobile phone wants to use Microsoft Teams. The new thing that's been introduced is you have this policy and identity management. And the notion is that if I do a robust multi-factor authentication with that policy and identity management service, that service can then make decisions about what other resources in the network I should be able to access. And so based on a risk assessment, again, we're starting with zero trust. So we have to slowly build trust in order to gain access to services. So a robust multi-factor authentication builds a lot of trust. If I'm using a device issued by my employer instead of a personal device, right, that might build incremental additional trust that allows me to access different services in the cloud. But based on some policy and my level of accumulated trust and authentication, it then can decide and broker encrypted sessions with different cloud services for me to access different services based on a risk score that is accumulated based on accumulated trust. So this allows us to achieve confidentiality and integrity, but not necessarily availability, because while I'm establishing these secure end-to-end encrypted sessions, there's no guarantee that a denial of service attack might not disrupt my underlying infrastructure. So this gets into the whole issue of supply chain, which is of paramount interest internationally today. Certainly within the United States, we have a lot of anxiety about the role that China is playing in the global telecommunications infrastructure. But beyond that, we also have a lot of open source software that is going into the core of our 5G networks. And so there's a lot of risk decisions that need to be made about the extent to which we trust all this open source software as delivering all the core services in this heavily virtualized cloud environment. So there's a lot of potential sources of risk and disruption, and carriers are perhaps less in control of a lot of these dynamics than they perhaps used to, because they're relying on a lot more federated, distributed cloud rather than fixed function equipment that they own and operate and deploy within their own data centers. So again, if you accept that supply chain is a broad risk that we need to address, then in this scenario, we can't guarantee availability, because whether it's malicious or faulty equipment, the components that are delivering the end-to-end service could fail either accidentally or on purpose. So one of the things that we're working on that I'm very interested in is how we extend the notion of zero trust. So first is we're looking at ways for the identity and management and policy engine really to get more visibility into the network. So within 5G, we have this orchestration layer that's responsible for gluing together all the different resources and managing those resources to deliver services to the users. And if we could expose really how the network is configured to that policy and identity management service, and we could now establish a root of trust that goes all the way from the physical hardware through the logical hardware, through the virtualized service that's running on top, we could establish trust not only in the endpoints of the network, but also in the core of the network itself. And if we see problems or parts of the network where we aren't able to establish a threshold level of trust, then we can do dynamic reprovisioning that can route traffic a different way through the network. So just as a simple example, imagine an SD-WAN session where I'm able to route traffic through a direct fiber link or through some sort of MPLS network. And I know that I can trust the direct fiber link. I don't know if I can trust the MPLS session. And as a result, if I'm load balancing between the two, I may put more sensitive traffic over the direct fiber link because of some sort of policy orchestration decision that's made by a zero trust architecture that's sitting over top. And so this is the direction that a lot of folks in the United States are thinking is really the future. But again, this is still very early stage technology, and it's not as though you can go out and buy a product today that does this kind of service. So I think this is really aspirationally where we look to go for the future of 5G security. So with that, I guess I'm done with my remarks. So let me stop, and I think we can open it up to a broader discussion with the other panelists.
Yeah, thank you, Charles. Very qualifying, and I think we have enough to start a roundtable. Together with Dr. Charles Clancy, we have my colleague at Mobile World Capital Barcelona, Federico Ruiz. He's the head of the 5G National Observatory. Hi, Federico.
Hello.
And we also have Dr. Sergi Figuerola, CTIO at I2CAT and CTO at 5G Barcelona. Hi, Sergi.
Hello, good evening.
Okay, let's start just less than a minute. Federico, what do you do at the National 5G Observatory? Less than a minute.
Well, exactly what we're doing now, addressing the questions of public, of industry, and a very important thing, which is raising the message and the awareness that 5G is an excellent opportunity for economic growth and economic recovery now, we have to say.
Okay, thank you. And Sergi, 1 minute. What do you do at I2CAT?
Yeah, well, I would say that we create and we develop technology, not only 5G technology, but also the convergence of technology, which means to put together into 5G, which is artificial intelligence, cybersecurity, and so on. So we develop this technology, and then we pilot this technology into different trials that we have. But some could be in the lab, but mostly on the city, because we think that this is quite important. And then also in 5G Barcelona, what we try to do is to to make people understand the importance of 5G by means of deploying city trials all around where people can see in a tangible way the added value that 5G might bring to them. Thanks.
Thank you, Sergio. Okay, let's start with a very open question. From what I understood, I'm not technical, okay, but from what I understood, we can say that 5G is the most secure standard today. Why is that, Charles? How would you explain this concept of security and standard to a generic audience?
So I would completely agree that 5G is the most secure standard for any sort of mobile or wireless communication that's ever been developed. I guess I would caution that it is also new, and we're just now building and deploying an extremely complex network. So while it's perhaps the most secure standard, I expect that we're going to find all kinds of challenges we begin deploying a global network based on the technology that will lead to a few bumps in the road as we learn from mistakes. So I expect we'll probably see a few security challenges early on as we sort through the technology. But after we get kind of through that bumpy startup period, I think we'll have the building blocks for the most secure global mobile infrastructure.
Okay, thank you. Federico, Sergi, if you want to add something or comment something about it, feel free.
I think thank you, Juan. I think this question is important because a lot of people of different technical backgrounds, degrees of technical backgrounds are watching us. They will hear about lots of things coming, lots of possible issues, and we're all excited about answering these needs. But also we want to reassure them that 5G has been conceived from the start with security point of view. It even has a mission critical profile that makes it paramount to address cybersecurity. So we're fixing, the mobile industry is fixing many of the legacy problems and issues that it has found over years of evolution, coming from just simply talking on the phone.
Good. Yeah. Well, following you, Federico, I agree with Dr. Clancy's opinion about the security features that 5G will have. Although maybe one of the things that we might have to take care of is the fact that we know that 5G is not just coming from scratch, so different phases. It's a migration. We might have first 5G and SA, then afterwards SA. And the issues that we might have at some point, an infrastructure which is, I would say, security by design, which is 5G, dealing together with a 4G infrastructure, which at some point the issue is that both infrastructures working together might happen that there are some weakness that some people might use in order to change the behavior of the network or so. What do you think on that, Dr. Clancy?
Charles, if you want to add
Sorry.
something. Yeah.
Yeah, no, I think that's very important. So the more we can establish testbed environments to begin prototyping and exploring these different use cases. So I'm a firm believer that we're gonna learn a lot as we begin exploring through the lens of specific use cases. So rather than necessarily trying to solve all the security problems just in a generic sense, we should say, all right, well, we want to deploy smart grid over 5G. Well, what are the security requirements of smart grid over 5G? And how can we prototype and explore and test and debug through the lens of a specific application? If we want to do autonomous vehicles, or we want to do Industry 4.0 use cases, again, how can we build a sort of vertical integrated ecosystem around that can provide a concrete set of examples around which we can explore the security properties. It's impossible to build a system that's secure against all hypothetical threats, right? And so we really need to move away from the hypothetical space and look at the very specific cases and have that be application driven.
Okay. So Federico, this one's for you, because we are talking about the future, but I'm sure that our audience would love to have a clear picture of today's state of the art in 5G cybersecurity and how it will evolve. Okay, I think Dr. Clancy has talked about zero trust networking, but could you add on something?
Well, the state of the art in 5G cybersecurity is constantly evolving. We're just discovering it and improving as we work. First of all, the mobile 5G situation is in fact a meeting of several worlds. We have the mobile world, which is the legacy coming from the 2G worlds. We have the cloud and internet world. This is why we have, from the meeting of these two worlds, we have to speak of cybersecurity, not just plain old mobile security. And we also have something which is completely new, which is profiles that go way beyond person-to-person communications. We now have things. Things are both very simple, sensors, counters, devices that have to be battery powered. And we also have things that can be as complex as an autonomous car potentially. So this creates a scenario is going to be very, very complex to requirements to satisfy. So the obvious reply that the industry is having for that is, let's use the tools that we have, AI, the state of the art in cloud design, evolving from microservices, zero trust networking. We have to emphasize every tool and mean that we have to make more robust the supply chain. We are really using all these tools at the same time and making them evolve. We're going beyond, and I hear that a lot from both technology vendors and mobile operators, from a world where we're still using AI, state-of-the-art AI, like machine learning, to reasoning. We have to learn how to use these techniques in mobile networks. We have to know if an AI is detecting some issue in a network. We have to know if this is a real issue, if it's a threat, if it's a failure, if it's something that we have to address, reply to, beef up resources, replace, or react in some other way. We will need to have complete diagnosis from the AI. Explainable AI, for example, is an important thing here. So it's really a job that we're just starting to tackle. And I like the remark from Professor Clancy about some of these things working right now only on paper or on PowerPoint. And I will say this is not a reason to just wait and see for the mobile industry and internet industries to react. This is exactly what creates the big industrial economic opportunity of 5G networks. This creates a gold mine of potential startups, new companies, service companies, experts. And doing all that with things in the loop, with mission critical services, with sub-millisecond reaction times, is going to require a completely new league of software development skills.
Yeah, and I'll just reinforce the AI component with the Open RAN technologies that are currently being developed. Open RAN looks at decomposing the base station into multiple subcomponents so you can increase vendor diversity and inject more innovation sort of in the middle of the base station technology. One of the key use cases they're looking at is how you can build this radio intelligent controller, or the RIC, which is able to use machine learning to do real-time adaptation of how resources are allocated in the radio edge of your network, deciding which users get which frequency slots and time slots when, in order to satisfy the diverse set of quality of service needs of your network. So this is really exciting. But it's also a little bit scary as we are intentionally handing a component of our network management over to an AI approach. I think it's the future for 5G and beyond 5G, and we're just now starting to see it emerge in some of the standards.
Yeah, Well, I actually think that this is the beauty of this world, right? That the challenges that we have ahead, because it's not something that, I mean, as Dr. Clancy was saying before, there are many things that we don't know yet how they will perform or what we will need to solve them. But coming back onto the issue that not only the fact of the ORAN, where we will have this the coupling of the base station, which means that there could be multiple players getting into the game. We also have the open source solutions. We know with 5G, we have several access technologies. And in the end, you realize that all the topics that you commented before about virtualization, about the different layers, we might have also different types of governance in the future of cybersecurity or security itself. Because whenever we are providing a service, we might have the infrastructure provider, we might have the service provider, we might have the application provider, plus many other actors that are playing there. And at the end, who is the end responsible to be sure that the application that you are running is properly secure when you are crossing so many different, I would say, entities or organizations that are handling part of this infrastructure. And I think that here is a key challenge also to know exactly what type or what type of different frontiers we have of responsibility of this security, I would say, performance of the infrastructure and the service in the end.
There is also an added dimension, which is let's not forget that this is not a technical exercise, but it has some profound economic consequences. And we want technology providers to make money with that, to make secure equipment, but also equipment that can compete with our competitors. And if we build too much of computing resources, for example, we may run into perfectly good equipment at running AI, but are on overkill on price. And we've seen these in the last 1 or 2 years. And these can create gaps in the supply of solutions, delays in the deployment of 5G. And this is a big issue. At the same time, if we have a look at IoT, for example, we don't want to have too much difficulties on building IoT, stifling innovation. And IoT and the innovation bands are there because they are dynamic and because we have a very fertile and dynamic innovation arena. So we don't want to kill that.
Okay, I have this. Did you want to say something, Sergi?
No, it's okay.
No. Okay. I have a screen in front of me. I can see your faces. I see you're starting to have fun. Okay, that scares me. Okay, so I'm going to ask a question for you, Sergi. Okay, let's go a little bit more concrete. As we were talking before, some 3 years ago, we oversaw this scenario that it's about to happen soon. A huge amount of connected objects from so many vendors, okay, will be connected to the 5G network. And I would like to understand, or how do you think IoT and mission critical applications like connected cars, autonomous cars will impact cybersecurity? So do you think that we will be able to deploy reliable, safe, and secure mobile communications for these new scenarios?
Well, the answer would be that we have to. I mean, it's mandatory because it's not that we will have different elements across the network that will provide connectivity. It's that all of them will be interconnected. Whenever we are discussing about B2X or B2B communications technologies between cars or between cars and infrastructure, it's not just a communication in order to download a film and to watch this on the car. It's just to provide information where we are, where the other cars are, what is the mobility pattern that we have across the city, and also maybe is interacting with the user's mobility that you have, with maybe thousands of sensors, which means that we have many points of entrance that needs to be coordinated, that need to be controlled, because whenever now, for example, you are just changing something on a sensor or entering through a sensor, you might end up having a higher impact in the whole infrastructure that we are dealing with. So I think that it's going to be completely important that not only the ones, I mean, the technology itself to be secure, also the agencies that we have behind, because we have many councils that aims to provide smart city solutions. But these smart cities, I would think that they should change the name to smart and secure cities, because what you need to have is the confidence of the people. And in the end, we know that many of us has many apps that you always accept anything that they ask you in order to have the app running on your mobile. But this is something that it's personal, you're responsible of it. But whenever you have to rely on other information, which is another one which is providing it to you, I think it's very important that there is a certain level of security that assures that there is I would say, a right provider providing this information. And here maybe you can even put blockchain technology, right? But we are in a converged world, and this is the challenging.
Okay. We are starting to receive some questions from the audience related with one thing you were talking right now. Tony Garcia, he wants to know about the human factor, and he asks, are humans becoming the weakest link in networks? So who's answering?
So I think from a purely security perspective, humans are often the weakest link. We still see the majority of intrusions are the result of phishing attacks via email. I think that it's more than 90% of intrusions into, say, enterprise networks are the result of social engineering or email phishing attacks. So robust training is really needed to help with basic cyber hygiene in your networks. I think there's a lot of things the networks can do to make it easier for users. So for example, the FIDO Alliance is looking to establish multi-factor authentication approaches for mobile that eliminate the reliance on passwords. I think that would be a huge step forward from a human factors perspective, because the password is often one of those weak links that relies on the user. And if we can begin to make it easier for the users to do the right things, then we'll ultimately have more secure systems overall. But of course, as we move into this Internet of Things, it's going to be a very different dynamic as well, because now you have things that are authenticating and using the network and interacting with humans in a just in the environment, in a built environment sort of scenario. So there's, of course, then a lot of privacy things that we need to sort through and understand as we enter that future as well.
Well, I also agree that the citizens maybe are the most vulnerable just because they are at the last position in the chain, right? But I think that our challenge is to make them much more aware about the importance that they request or they check these security functionalities that they have, because we are entering in a really digital world, let's say. And also one of the topics that in the presentation was showed is that we are moving also to the softwareization of the infrastructure. So we have thousands, millions of pieces of software which are running around and performing actions that before maybe were only provided by one box. So I think that it's important that everyone is just confident that now you have to be a bit more, I would say, more demand requesting whenever it's dealing with security, whenever you want to have a proper interaction with the infrastructure of the network.
Okay, so let's move a little bit from 5G strictly. Dr. Clancy, we would like to know what are the different approaches in different parts of the world in terms of data governance, privacy, and security. This is a topic that would require another session like this, but I think it's interesting to know your opinion.
So I think the internet is at a sort of existential point in trying to figure out its path forward for the future. I'll notice there's a few large themes that are happening. One, the hyperscaler cloud service providers, such as Google and Microsoft, Amazon, Alibaba, they are increasingly responsible for delivering our content and our network traffic. Tier 1 internet service providers are less critical to the delivery of backbone traffic across the internet now than they were 10 years ago. So we're seeing a shift to the expansion of the large content providers having a global footprint and global points of presence. Google, for example, has 4 undersea cables of their own that they operate privately and has, I think, over 1,000 points of presence all over the world. So the topology of the internet as we know it is changing under our feet. At the same time, we're in the midst of some fairly large geopolitical challenges with sort of the East versus the West. So, of course, China has the Great Firewall of China, which is a big platform for censorship within the East. And as China exports more of its technology through the Belt and Road Initiative, we're beginning to see kind of more of the world align behind the Great Firewall. Meanwhile, the US is certainly getting more aggressive with its stance, and we've recently launched the Clean Networks Initiative, which has potentially similar objectives that is further fragmenting perhaps the internet infrastructure. Of course, the EU has just over the last several years rolled out the GDPR privacy regulations, which is yet another sort of view on how we manage and control digital sovereignty and sovereignty of data and privacy. And so, and then against that backdrop, you have China, who has now introduced new IP, which is an entirely new internet protocol, which has lots of interesting technical features, but again, from a geopolitical perspective, could drive a wedge between the East and the West of the internet. So I think there's a lot of interesting technology we're talking about in 5G, but I think we're also facing sort of an existential next phase of the internet, and whether we're able to really maintain an open global internet that we, to a certain extent, have today, or whether we end up fragmenting either because of the role of the large-scale cloud providers and service providers, the balkanization of the app ecosystems, or the underlying protocols that we use for internetworking. So it's a very interesting time, and I certainly don't have all the answers, but the internet could look very different in 10 years than it has for the last 30 years.
So in the end, coming back to what you said, I think that we are lucky. I mean, we are the generation that has properly lived in an open and unique internet, because what might happen is that we end up having different internets of internets, which means that depending on what you want, you will have to be in one internet or another internet, and will somehow destroy, I would say, the beauty of having one unique infrastructure, what is worldwide, connecting everything and everybody, right?
Yeah, absolutely. And we are going to see soon things evolve in predictable ways. We have, going back to the start of the session, we started discussing about the 5G standard. We have several strongly related standards, either official standards or de facto standards or practices that are going to fragment potentially the network into different realms. We're also seeing from a European perspective, we are trying to put in place something that serves as a common ground for different economic and geostrategic areas. And we're running into the limits of enforcing or imposing this view if you don't have a technical muscle to back this. So we should really react in Europe and have a new place into this rethinking of the internet.
Well, we could say now that maybe in Europe there is a new wave of technology sovereignty, right? Which in the end might try also to bring much more innovation, because it may end up having much more players into the game, because then is what is needed to be sure that innovation keeps into the top.
Technology's sovereignty is a completely new concept in Europe that we didn't hear about 1-2 years ago, or barely.
And Federico, I don't know if you can answer this one. End-to-end encryption or law enforcement?
Well, law enforcement agencies are going to have an interesting time as well, because we started saying that 5G is a very secure standard. It is even more so because it's going to be deployed very often with end-to-end encryption. So the customer is going to have a big say on how his security level is going to be. So if governments don't answer the need for privacy and regulation, customers, individuals, and some players may take this into their own hands.
Good. Okay, Beatriz Ucieto, she's asking, could security concerns between different partners be overcome with the development of standards? For example, in the case of smart cities?
So I think it would be very interesting to so smart cities are an example of a hyper-connected environment with a significant amount of data being collected and potentially archived and stored. So my personal view is that it would be great to develop standards around the aggregation and storage and fidelity of data. So for example, if you have a HD video camera whose sole purpose is to act as a motion sensor, there's no reason to archive the full HD video stream in perpetuity. So if we could begin to develop standards around how we aggregate the fidelity of data we actually need in order to implement the services we want in a smart city, I think we would be able to eliminate a lot of the privacy compromising data archives that ultimately get hacked and then used in inappropriate ways. So I think standards could play a big role, but you have to be able to intersect the privacy policy aspirations with the underlying technological use cases. And we haven't really nailed down either yet. So it's hard to figure out what their intersection is.
Some of the economic potential of 5G is going to come from a combination of 5G and AI and the blockchain technologies. So we may think of new standards for enforcing what you just described. If blockchain was designed to answer the double spending of currencies, of digital currencies, we may think of some standards regulating how many times we access data, how we protect them, preventing certain uses of them, and have this built and together with data. It's again an exciting area of development for future standards.
Well, in the end, the standards is the means that we have to provide interoperability with all the different elements that you have in the value chain. And these are the ones that have to put the rules on how we have to, I would say, how we have to handle the information, how we have to manage them, and up to what extent we have to make one action or another. So I think that they are key for the success also of the technology.
Mm-hmm. Okay, I think we have time for one more question. Carlos from Barcelona is asking, what implications can security have to municipalities deploying the new IoT technology and vehicle to infrastructure? Should we talk about smart and secure cities?
Well, I think that this is what we were discussing before, right? That we have to talk about smart and secure cities, just because we have different elements. It's not just about IoTs. We pretend to have everything connected, and when everything, we talk to the urban mobility, vehicles which are moving around, people. So here it's important that there is the concern on the cities that if they really want to provide added value, not only information but data that is used by the vehicles or the citizens for any action they make, that the information they provide is properly secure. So you have to go also to be sure that whenever a sensor is deployed, the sensor is controlled. Maybe at the edge computing element, which is providing some algorithms over these IoT devices, is where you have some frontiers that you check different patterns with by means of AI, machine learning technologies. But indeed, it's going to be important that security or cybersecurity is implemented in all these city infrastructures.
Mm-hmm. Good. Okay. As a conclusion, in 1 minute for all of you, okay, where do you think we shall be addressing our efforts nowadays in terms of cybersecurity? Dr. Clancy?
Well, I mean, as I talked about in my keynote, I think we need to really begin to turn the PowerPoint into tested and interoperable and deployed solutions. So there's a lot of great ideas in zero trust architectures, but we'll learn a lot by deploying them at scale. There's a lot of great ideas around how we can secure roaming interconnects for 5G networks, but none of it's been tested yet. I mean, here in the US, we have a small test bed among the US carriers to try and begin experimenting with how that would work with release 16 of 3GPP. But again, we haven't we haven't actually done it yet. So I think the near-term opportunity for a lot of this is really let's start trying it out and see what happens and learn a lot along the way.
Federico.
I agree. We have to start with the pilots and the setups that we have. We have to go beyond the application, simple application, to get really operations running and see and even exercise attacks against and threats against these networks and see how they react. It's only then that we will really learn if we are going in the right way.
Yeah, well, I would say the same. It's a question of keep trying. And I think that maybe now that you suggested this, one of the things that we should do in 5G Barcelona too, as you said, we have been running, or we have on the way 100 use cases, but we maybe mostly talk about the HDTV streaming, I would say the high bandwidth, the low latency, but maybe we don't put enough emphasis on, and all this is with this level of security, or is with this mechanism, or with this machine learning algorithm that it's providing you this security. And I think that we should start putting security as one of the, I mean, Dr. Clancy before was telling about the 3 services that 5G will bring as a promise, right? But we have to be sure that all these 3 services will have to be secure. So maybe at the end, security is going to be another pillar that will span across the whole services, and we have to give the proper importance to that.
Okay, the team unfortunately tells me that we've run out of time. It's been an absolute pleasure to have you all 3 sharing experiences, knowledge, and thoughts, and we hope to enjoy the second round sooner than later. Thank you, Dr. Clancy. Thanks again to the U.S. Embassy in Spain and Andorra. Thanks, Federico, Sergi, and to our audience. We hope you've enjoyed the session as much as we did. Please keep connected to Mobile World Capital social media profiles, where we will keep on sharing contents, and you will be informed about future Mobile Talks formats. Hope to count on you soon, Dr. Clancy, here in Barcelona. And see you soon, and take care.
Thank you.
Thank you very much. It's been a pleasure.
Same. It's been a pleasure.
Bye.
Thank you, God. Bye.